Welcome back to Decentralized Application Development Crashcasts. I'm Sheila, and as always, I'm joined by my co-host, Victor. Before we dive in, I want to remind our amazing listeners that if you're enjoying our content, please take a moment to rate our podcast on your favorite platform. Your support means the world to us.
Absolutely, Sheila. Your feedback helps us improve and reach more developers interested in decentralized systems. Now let's get into today's topic, shall we?
Definitely. We're currently in Chapter 4 of Season 1, focusing on decentralized storage systems. Today we'll be exploring data retrieval strategies. But first, I have a quiz question for our listeners. Ready?
I'm all ears, Sheila. Let's challenge our audience.
All right. Here goes. In a decentralized storage system with 1,000 nodes, each storing a copy of a 1 GB file, what's generally more efficient, retrieving the entire file from a single node or retrieving small chunks from multiple nodes simultaneously?
Oh, that's an intriguing question. It really makes you think about the trade-offs in decentralized systems. On one hand, getting everything from one place seems simpler, but on the other, leveraging multiple nodes could potentially speed things up. I'm curious to see what our listeners think.
Exactly. We'll reveal the answer at the end of the episode. Now let's start by defining some key terms. Victor, could you explain what we mean by data retrieval in the context of decentralized storage?
Certainly. In decentralized storage systems, data retrieval refers to the process of accessing and fetching stored information from a distributed network of nodes. Unlike centralized systems, where data is stored in a single location, decentralized systems spread data across multiple nodes, which introduces unique challenges and opportunities for retrieval strategies.
That's a great explanation. So, how have data retrieval strategies evolved in decentralized systems? What prompted their development?
Great question. The evolution of data retrieval strategies in decentralized systems has been driven by the need to overcome the limitations of traditional centralized storage. Initially, simple methods like flooding the network with requests were used, but these proved inefficient as networks grew larger. The development of more sophisticated strategies was prompted by several factors. 1. Scalability. As networks grew, more efficient ways to locate and retrieve data were needed. Point 2. Fault tolerance. Strategies had to account for node failures and network partitions. 3. Performance. Reducing latency and improving throughput became crucial. 4. Resource optimization. Minimizing bandwidth usage and load on individual nodes became important. These factors led to the development of various retrieval strategies we use today.
That's fascinating. It sounds like there's been quite an evolution. Can you walk us through some of the basic retrieval methods before we get into more complex strategies?
Absolutely. Let's start with two fundamental approaches, pull-based and push-based retrieval. Pull-based retrieval is similar to how you'd borrow a book from a library. When you need data, you actively request it from the network. The system then locates the nodes that have the data and retrieves it. Push-based retrieval, on the other hand, is more like subscribing to a magazine. Nodes with new or updated data proactively send it to other nodes that have expressed interest in that type of data.
I love the library and magazine analogies. They really help visualize the concepts. So, in your opinion, which approach is generally more efficient?
That's a great question, Sheila. The efficiency really depends on the specific use case. Pull-based retrieval is typically more efficient when data is accessed infrequently or unpredictably. It conserves network resources because data is only transferred when needed. Push-based retrieval, however, can be more efficient for frequently updated data or when low latency is crucial. It ensures that nodes always have the most up-to-date information without having to constantly check for updates. In practice, many systems use a hybrid approach, combining elements of both strategies to optimize for different scenarios.
That makes a lot of sense. Now, let's delve a bit deeper. I've heard about something called content-addressable storage in the context of data retrieval. Can you explain what that is and how it relates to retrieval strategies?
Certainly, content-addressable storage is a method where data is stored and retrieved based on its content rather than its location. In this system, each piece of data is assigned a unique identifier, often a hash, based on its content. This approach is particularly powerful in decentralized systems because it allows for efficient data retrieval without needing to know exactly where the data is stored. When you want to retrieve data, you just need to know its content hash, and the system can locate it across the network. It's like if every book in a library had a unique code based on its content, and you could find the book just by knowing this code, regardless of where it's physically placed on the shelves.
That's a really clever system. It seems like it would solve a lot of problems in decentralized networks. But I'm curious, are there any challenges or drawbacks to using content-addressable storage?
Great question, Sheila. While content-addressable storage is powerful, it does come with some challenges. Point 1. Hash collisions. Although rare, two different pieces of content could theoretically produce the same hash, leading to conflicts. 2. Mutable data. It's not inherently suited for data that changes frequently, as any change in content results in a new hash. Point 3. Privacy concerns. The content hash might reveal information about the data itself in some cases. 4. Overhead. Generating and managing content hashes adds some computational overhead to the system. Despite these challenges, the benefits often outweigh the drawbacks in many decentralized systems.
Thanks for highlighting those challenges, Victor. It's always important to consider the trade-offs. Now, I've also heard about DHT-based retrieval. How does that fit into our discussion of retrieval strategies?
DHT-based retrieval is a key strategy in many decentralized systems, Sheila. DHT stands for Distributed Hash Table, and it's a way of distributing data across a network of nodes. In DHT-based retrieval, each piece of data is associated with a key, often a hash, similar to content-addressable storage. The DHT then provides a lookup service that efficiently maps keys to nodes in the network. When you want to retrieve data, you first calculate its key, then use the DHT to find which node or nodes are responsible for storing that data. It's like a decentralized phone book. You look up a name, the key, to find the corresponding phone number, the node storing the data.
That's a great explanation. It sounds like DHTs could be really efficient for large networks. But I'm wondering, how do DHTs handle node failures, or nodes joining and leaving the network?
Excellent question. DHTs are designed to be robust in the face of network changes. They typically use techniques like Point 1. Replication. Data is often stored on multiple nodes, so if one fails, others can still provide the data. Point 2. Consistent hashing. This technique minimizes the amount of data that needs to be moved when nodes join or leave the network. 3. Self-healing algorithms. When nodes detect that a neighbor has failed, they can automatically adjust their routing tables. 4. Periodic health checks. Nodes regularly check on their neighbors and update their status in the network. These mechanisms allow DHTs to maintain efficiency and data availability even as the network changes.
That's impressive. It seems like a lot of thought has gone into making these systems resilient. Now let's talk about caching. How does caching play a role in data retrieval strategies for decentralized systems?
Caching is crucial in decentralized systems, Sheila. It helps reduce network traffic and improve retrieval speed. In essence, caching involves storing copies of frequently accessed data closer to where it's needed. In a decentralized context, this might mean Point 1. Local caching. Nodes keep copies of recently accessed data. 2. Edge caching. Data is stored at strategic points in the network. Point 3. Popularity-based caching. Highly requested data is replicated more widely. Caching strategies need to balance freshness of data with the benefits of faster access. It's like keeping frequently used books on your desk instead of always going to the library. It's faster, but you need to make sure you have the latest edition.
That makes a lot of sense. It's all about finding that balance between speed and up-to-date information. Now, as we're nearing the end of our episode, could you summarize the key points we've covered about data retrieval strategies?
Certainly. Here's a quick summary of the main points we've discussed. 1. Data retrieval in decentralized systems involves fetching information from a distributed network of nodes. Point 2. Basic strategies include pull-based, request when needed, and push-based, proactive updates retrieval. Point 3. Content-addressable storage allows efficient retrieval based on data content rather than location. 4. DHT-based retrieval provides a scalable way to locate data across a large network. Point 5. Caching plays a crucial role in improving retrieval speed and reducing network load. Point 6. All these strategies aim to balance efficiency, fault tolerance, and data consistency in decentralized environments.
Thank you, Victor. That's a great summary. Now, let's reveal the answer to our quiz question. In a decentralized storage system with 1,000 nodes, each storing a copy of a 1 GB file, what's generally more efficient, retrieving the entire file from a single node or retrieving small chunks from multiple nodes simultaneously?
The answer is that retrieving small chunks from multiple nodes simultaneously is generally more efficient. This approach, often called parallel or distributed retrieval, has several advantages. Point 1. It distributes the load across multiple nodes, preventing any single node from becoming a bottleneck. Point 2. It can significantly reduce retrieval time, especially for large files. Point 3. It's more resilient to individual node failures or slowdowns. 4. It can take advantage of the aggregate bandwidth of multiple nodes. However, it's worth noting that the optimal strategy can depend on factors like network conditions, node capabilities, and specific system design.
That's fascinating, Victor. And it really highlights the power of decentralized systems. As we wrap up, I want to remind our listeners that if you've enjoyed this episode, please visit crashcasts.com, join our Discord community, or support us on Patreon. Your engagement helps us create better content for you.
Absolutely, Sheila. And don't forget to subscribe to the podcast and rate us on your favorite platform. Your feedback is invaluable to us. Thank you all for listening, and we'll see you in the next episode.